So here's a summary of what we've done so far. I've actually given you these as practice videos in the past, the first 5 here, and for this one I spent 7 videos explaining this. So if you don't understand these, then track back to one of the early videos, and from 3 to 6, for these 4 here, from 3 to 6, what x remains fixed, meaning that once a problem has been set, once you've set, let's say let x equal let x equal 7. Once that has been set, then x remains fixed. So it's 7 to the power of this thing here. Take the limit as n tends to infinity. So what is this saying is that x remains fixed once a problem has been set. Same with this. Once you set the problem, let's say x equals 3. Once you've set this, then it has been cemented. So x is now fixed. It doesn't change. So here limit as n tends to infinity. So what is it saying? It remains fixed. This x here doesn't change. It is the n that's moving to infinity. Once a problem has been set, then it doesn't change. Okay, and now we can make use of these to work out something more complicated. So for example, this one here, find the limit of this as n tends to infinity. So here you would make use of number 4. You would make use of this one here. You would make use of this. So remember, if you look at this here, if this number is smaller than 1, for example, let's say 0.37. Now, if you keep on timesing 0.37 times 0.37, the whole thing will just get smaller and smaller and smaller and smaller. Eventually, it will head towards 0. So this here, you can see this is smaller than 1, even though this is a negative. But if you keep on multiplying by itself, it's just going to get smaller and smaller and smaller. It's because this is less than 1. So eventually it's going to head towards 0. So here you would make use of number 4. Here you would make use of this one here. Okay. So next one here. Next one. So for this one here, what would be the limit of this as n tends to infinity? So here you would actually make use of number 2. You would actually make use of number 2 because for this one here, rewrite it as this. So the nth root is really this thing to the power of 1 over n, the nth root, and then you manipulate this, and then eventually you would get to this thing here. So hang on. So from here, rewrite it as this, and then remember x to the power of a to the power of b. These two multiply together to give you this. To give you this, and then you can break the 2 apart. So x, break the 2 apart. That will then give you this, and then this thing here is really the nth root. So this bit here, the nth root of n as n tends to infinity, is really you making use of number 2. It's really you making use of the number 2, because look, this is the nth root of n. As n tends to infinity, it will head towards 0. It will head towards 1. So the nth root of n will head towards 1, and then you've got to the power 3 to the power 3. So 1 to the power 3 will be 1. Okay. Next one here. So here, to work this out, you would make use of number 1. You would make use of this one here. So n, natural log of n over n. So when you take the natural log of something to the power 7, the 7 can come down here. So that will then give you this, and then now 7 is a constant. So when you take a limit, you can actually take it out here. So now this thing here is really number 1. It's really number 1 here. So the limit of natural log of n over n is 0. So natural log natural log of n over n, this whole block here is 0. So it's really 7 times 0, which is 0. Okay. Next one here. This one here. This one here. Well, here you're making use of two. Here you're making use of two. Sorry. Here you are making use of number 2 and number 3. So later on we're going to obtain this, and we're going to obtain this. So for this one, so in order to solve this one here, you need to make use of number 2 and number 3. So rewrite this as this. So imagine this thing here. Well, the nth root is really to the power of 1 over n. To the power of 1 over n. So that will then give you this. So now imagine as 1 here. So it's going to be this times this, and then this times this. That will then give you this. Hang on. So this times that. Well, and then this times this. Sorry, not time. What? I hope you understand. This times the index, the number 1 here, and then times the number 1 here. So that will then give you this times this. And then when you take a limit of a product, you can take the limit of this. So this is like one block and another block here, and then you can see that this here is number 3. This here is number 3. That's a constant to the power of 1 over n, which is 1. So a constant. So hang on. So a constant to the power of 1 over n gives you 1. So a constant to the power of 1 over n gives you 1. So if you look at this here, a constant to the power of 1 over n gives you 1. And then this one here, make use of number 2. If you look at number 2, the nth root of n. So the nth root of n is really there. So this thing here is the same as this. The nth root of n is 1. So hang on, down here. So the nth root of the nth root of n here will give you 1. So it's really 1 times 1. So this limit here will be 1. Okay. So it's really you making use of these to work out the limit of complicated sequences. Okay.